E-learning with NUT Endomorder Science School, Mina.
Good morning, or good afternoon, or evening, depending on what time you're viewing this video. You're once again welcome to another episode, another very interesting online class, all the way from Nutemss Model Science School, Mina. It's our sincere hope that you're staying safe and also observing all the safety precautions that there are, from social distancing to washing of the hands with soap under running water, down to using of the face mask, and also avoiding crowded places. Yes, very important. It's also very important that we all boost our immunity by eating healthy and good food, balanced diet, take enough water, and have enough rest as well. Today we're going to be looking at chemistry class year 8, and the presenter is none other than Teacher Haruna. Now, very quickly, our topic for today is acids and alkalis, or we call it acids and base. Very interesting topic, and the dimension or the method of which this topic is going to be taken is going to fascinate you so much that the ambiguity and the fear that you usually hear or your elder ones have told you about when it comes to acid and base will be unraveled. The aim of this lesson is basically two. The first aim is to understand the properties of an acid and an alkali, meaning how do I know if this is an acid and how do I know if this is an alkali. Then from there we're going to move on to the second objective, which is to identify different chemicals as acid or alkali or base, meaning we make use of different kind of chemicals every day in our home, at workplace, and everywhere we go. However, we don't even know which of these chemicals are either alkali or acids. So this lesson is going to take you through all this, and trust me, you're going to like it and you're going to enjoy it. Just like the pandemic, we're being told to be very, very careful and be safe at all times. This topic is one topic that requires a lot of safety measures and safety precautions. Either in the laboratory or wherever it is, you're going to deal with this topic. And because of that, I've also tried to bring out some of the symbols that you're going to see in the associated to this topic, especially the bottles or plastic that carries these chemicals. Now, some chemicals you will be using in this topic are hazardous, meaning they can cause harm to you, they can cause a lot of pain and a lot of injury if care is not taken. You may find various symbols on the bottle containing the acid and alkalis. What do they mean? Now, let's start from this one on the left hand side of my screen. And basically, whenever you see this symbol, it means that particular chemical is corrosive. And when something is corrosive, it can actually burn. It can eat up either your skin, the wood, or iron, depending on what surface it is. So it's very important that you handle it with care and a lot of safety precautions. Now we have other safety signs here which you're going to observe, because each chemical comes with its own level of hazard, and the precautions to avoid being injured is very necessary. Now, I have here an X sign with a little upper lowercase h, and what this means is that any bottle of chemical that contains this means that that chemical is harmful. It's harmful to your health. It can make you sick. Then down here, this is a sign of fire, meaning something that is burning. So, and whenever you pick a bottle of any chemical and you see this, it means that chemical is flammable. It can actually, with little ignition, it can actually catch fire and it will burn down everything. Then on this side, I have another X, but this time you can see there's a lowercase I here, which is what? Irritant. It irritates. It can make you to feel uneasy, especially when it has to do with breathing. Okay? So this is another sign that you can see attached to bottles of chemicals that we're going to be using as far as this course is concerned. Then the last one is toxic. Toxic, meaning it's actually also harmful, not good for your health. Okay? So these are some of the symbols that you're going to see in the bottles or cans containing some of these chemicals that we're going to make use of under this very interesting topic of acid and base. Now let's see, what's an acid? What is an acid? Basically, first, acids are substances. They are substances. They are not ghosts. They are not things that you cannot see. They are things that you can see. Okay, so they are substances that contain hydrogen ion as the only, as the what? Only positive ion. As the only positive ion. And positive ion is represented by this sign, plus H. So any chemical that has or contain hydrogen ion, yes, it's basically referred to as an acid. However, it is not all acids, or it is not all chemicals, yes, that contain hydrogen ion that are acid. Acid contain hydrogen ion, yes, but it's not all chemicals that contain hydrogen ion that must be acid. Now, go to the properties of acid. There are basically two types of acids that we know. There are strong acids and there are weak acids. And with the characteristics, properties that you can use to differentiate each of them. For strong acid, they are corrosive, meaning they can burn your skin, they can burn the wood or whatever. They can eat away at materials like metal, stone, and flesh. That shows that they are very strong. And their pH value is usually between 1 to 3 and 4 or thereabout. Then we have weak acids, which are not corrosive, but they have sour taste. Okay, they have what? Sour taste. Example like lemon and vinegar. These are acids. Okay, your lemon, the one, yes, that sun lemon that you know, yes, that looks like an orange, yes, it contains an acid. And that is why when you taste a lemon, it has this sour taste that it comes with. Acid contain hydrogen, but not all things that contain hydrogen are acids. So let's take note of that. Now on this part of the diagram, you can see a lot of items, about 5 items listed. You have salt and vinegar. And this vinegar contains what we call the ethanoic acid. Fizzy drinks, your soft drinks, your Coke, your Fanta, your Pepsi, your Mirinda, all these are fizzy drinks. And the other one is called as carbonic drink. And they contain what we call carbonic acids. Okay? Then you have the tea, yes, the Lipton, and the other brands of Lipton that you know. They also contain an acid called the tannic acid. Then the sweet orange that you take contain ascorbic acid, otherwise known as what? Vitamin C. Then the lemon, which I spoke about earlier, is actually has a type of acid called the citric acid. So all these are types of acid that you interact with every day. So you can see acids are not just the hydrochloric acid, the sulfuric acid, the nitric acid, and all of that. No, there are little things that you use every day that contain acids, and these are some of the examples. Acids. These are different types of acids. Okay, you will often find these acids in science lab. However, they can also be found naturally. Where else may you find these acids? The first one is ethanoic acid. Now, ethanoic acid is an acid that can be found in what? Vinegar. Vinegar is a plant. So it's a natural source of what? Ethanoic acid. Then you have hydrochloric acid. Hydrochloric acid can be found actually in the stomach. It aids digestion, especially neutralizing the pH of the stomach to ensure that the digestion is completed in good time and without injury to your stomach. And it also helps in killing germs that comes with the food you eat. Then the nitric acid is actually found in the car batteries. Yes, car batteries. How many of you have cars? Now that battery that actually is in the father's car contains what we call the nitric acid. Then lastly, sulfuric acid can be found in what? The paint that we use in painting our houses, our cars, and what have you. So all these are sources of acid that we have, and these are the natural sources of these acids as well. Now, what type of acid do these items contain? The first one here, I have lemons. Lemon. Now, what type of acid do lemons contain? Remember earlier in our in the just concluded slides, we said that lemon has what we call the what? Citric acid. And you can see, just as highlighted, citric acid. Lemon contains citric acid. Now you have this. This is an ant. Okay? Ant. Yes, that ant that stings you. Yes. As in ant, yeah? Yes, that's an ant. An ant has what we call ethanoic acid as its excreta. It actually excretes ethanoic acid as its only what? Waste. And that is why the moment you are actually stung by an ant, you feel this irritating pain in your skin, because that is the effect of the ethanoic acid. Then we have the phosphoric acid in the fizzling drinks like we have in the Coke, Fanta, Pepsi, and all of that. Okay? We also call it carbonic acid, right? Don't forget, also call it carbonic acid because they are carbonated drinks and they contain that. Then here I have the tannic acid. The tannic acid actually has something to do with the what? Tea. The lifting and the other brands of lifting that you take. Okay? Then lastly, but not the least, we have the what? Lactic acid. And the lactic acid is found in what? The milk we take. Sometimes you go to take the local milk, either Fradinono or Kindirmo, and you find out that they are very sour. This is the effect of the acid that is making it to be what? Sour. Now, these are acids around us. We have some other type of acids that are found in the laboratory, which I'm not going to mention here. Or perhaps we're going to mention them briefly, but we're not going to discuss them in details because this is not the appropriate class for that. And these are acids like the hydrochloric acid, HCl, the trisulfuric acid, SO, SH, now we're finished talking about acids, the types which are strong and weak acids, and the properties of these two acids. Whereas the strong acid is corrosive, can burn and eat away at materials, the weak acid we say is sour. Now, let's look at what the bases are. What are bases? What's a base or an alkali? Now, just like we define hydrogen, acids, we're going to attempt to also define alkalis. Alkalis are substances as well. They are not ghosts. They are not things that you cannot see. They are actual substances that contain hydroxide ion as the only negative ion. As the only negative ion. And the negative ion is represented as minus OH. So, substances that have the OH ion in them have tendencies to be alkalis. But just like we said, when we're talking about acids, it is not all substances that contains the hydroxide ion that is perhaps alkali as well. You can have them in some other minerals and substances, and yet they may not be what? Alkalis. Let's look at the properties of alkalis. One of the major properties of alkali is that they feel soapy to touch. When you touch them, they are slippery like soap. Yes, that's how you recognize or you get to identify a base or alkali. They are soluble bases, meaning they can dissolve in water. Yes, they can dissolve in water. Then, like acids, they can burn the skin. Strong base can actually also have a corrosive effect, like the acid, and burn the skin. Alkalis contain hydroxide ion, just like it has been actually pointed out in the definition. And lastly, they taste bitter. Yes, some of you have eaten things that are bitter before. Let's say, for example, chief bitter substance, which you all know, bitter leaf. Yes, so that is basically some of the examples. Now, in the science lab, you often find these alkalis. Alkalis are also present in these objects, which I'm going to list for you now. However, we have ammonium hydroxide, which is an alkali, calcium hydroxide, another alkali, and sodium hydroxide. These are 3 alkalis. Now, where can you find these alkalis? Among the things we use on a daily basis, like we did in the acid. Now, this is a cleaning agent, like your soap, like your detergent, like your Morning Fresh, like your Hypo. Yes. So all these are cleaning agents, and they often contain ammonium hydroxide. This is a baking soda. Yes, it's also an example of a base or alkali which we make use of every day in the house. We have the wasp. Yes, the wasp is another insect that actually excrete, or when you're stung by a wasp, that irritating feeling is actually coming from that substance, which is an alkali deposited in your skin. So wasp stings are actually also alkaline in nature. Then you have soap, which is also alkaline in nature. You have indigestion tablets, like your Gestid, like your Gelosil, like your Magsil, whatever, name them. All those drugs that you take for indigestion, they're actually made from base or alkalis. Then your toothpaste is also another alkali, which we use on a daily basis. Now, after the alkalis, there is something important we're going to look at, and that will be the pH scale. Now, there's what we call pH. pH is simply the level of acid or alkali present in a substance. Normally, some substances are more acidic than the others, and some are more alkaline than the others, whereas some are basically neutral. They are neither alkalis nor base. So the pH scale is what helps us to determine the level of acidity or the level of alkalinity that is in that substance. The pH scale is basically a scale which is numbered 1 to 14. Yes, it's numbered 1 to 14. And 7.5 is actually the neutral point, meaning at 7.5 it is neither alkaline or acidic. Now look at this. This arrow indicates to the left that any substance that the pH is actually indicated by the numbers on the left hand side. 0, 1, 2, 3, 4, 5, 6, 7, 7, 7. Then those substances are actually acids. And whatever you get from 7, 8, 9, 10, 11, 12, 13, 14. They are actually alkaline. So when you test a material, the pH of a substance, and it falls between 4, 3, 2, 5, 6, you should know that that material is an acid. And if you test the pH of another material and it falls above 7, 8, then you should know that that material is actually an alkaline material. You can use indicators, so that the indicator, the litmus paper as well, to be able to ascertain if the substance is either acidic or basic. Now, from the right hand side, like I said, is acidic. The left hand side rather is acidic, and the right hand side is basic. Now, let's look at this. Between 0 to 7.5 is acidic. The less or smaller the number, the stronger the acid. The higher the number, the weaker the acid. 7.5 is neutral, neither acidic nor basic. The same thing between 7.5 to 14 is basic or alkaline. The higher the number, the stronger the base. Yes. Remember, in acid, we said that the less the number or the smaller the number, the stronger. But in the case of the base, the higher the number, the stronger the base. The less the number, the weaker the base. 7.5 is also the neutral point, neither acidic nor basic. So these are how you identify it. Now, very important, another part of this topic which we're going to look at is what we call neutralization. Can you say it after me? Yes, go on. Neutralization. 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 Okay? You can either spell it with S, British English, or you spell it with Z, American English, whichever way it's allowed. So neutralization simply means the reaction between an acid and a base or alkali to form salt and water. Meaning that point where it is neither you have a base and you have an acid, you react them together, and the resultant product will be salt and water only. Now, neutralization moves the pH of an acid close to 7 from 1, while also bringing back the pH of alkali close to 7 from 14. So when you do neutralization, it means you have been able to cancel out the acidic effect and the basic effect of that material, and it is no longer an acid or a base. So basically, that is what neutralization does. Now, in everyday life, we're going to look at some examples of everyday neutralizations. What can you do if some things happen to you in your house? For example, you got stung by a wasp, which is basically an alkali. Now, to neutralize them, we use an acid like what? Vinegar. Yes, if you get stung, it's a basic first aid for wasp sting. So if anybody in your family gets stings by a wasp, all you need to do is to get a vinegar, you apply to that spot where the wasp actually stings the person, and then automatically you're done. The same thing, bee stings are acidic. Yes, because bee is an insect. I remember I say that acid, insects have what? Yes, as their end product, acid. Now, to neutralize them, we use an alkali like what? Baking soda. So, ladies and gentlemen, we have given you a first aid for what? Bee sting. So whenever you get stung by a bee, don't cry, don't shout all about looking for. Just get to baking soda, apply to the spot where you were stung, and the rest will be stories. More on this everyday neutralization. Acid in our mouth damages our teeth because the continuous bacterial effect of trying to either feed on whatever the left crumbs are attached to our teeth actually create an acidic atmosphere in the mouth. Now, to neutralize the acidic effect, we use brush. Yeah, we use brush. We brush our teeth with what? Toothpaste, which contains alkali, and you have the mouth smelling nice and good. You understand? So, if you have this strong mouth odor, you should know that it's basically because the acidic content of your mouth is very much. And if you want to, the only way you can be able to neutralize it is to use an alkali, which is what? The toothpaste. And you can also see why some people use what? Ashes in brushing the teeth, because ash also contain what? Alkalis. Now, acid rain can make the soil acidic. To neutralize it, their acid soil, farmers and add alkali, which is what? Lime, to their field. There's a lime that when a land is acidic, it can be added, and that is all. Neutralization, like I said, it's actually a reaction where base and acid react to form salt and water only. And now, the product of neutralization, mix together an acid and alkali in an evaporating dish. What two things need to be kept the same? These are practically actually something we're going to do by the time the school resumes fully. You cannot do it on your own. You have to do it under the guide of the teacher, which is going to be in the laboratory. So basically, this is vinegar.
Ew. Dear Tim and Moby, how can I find the pH of water? From Jules So Cool. Well, the pH refers to the chemical potential of hydrogen. The pH scale measures how acidic or basic a substance is on a scale of 1 to 14. On the acid side, which measures from 1 to 7 on the pH scale, you can find things like vinegar, lemon juice, battery acid, and the hydrochloric acid in your stomach. On the base or alkaline side, from 7 to 14, you'll find things like soap, toothpaste, baking soda, and floor cleaner. Really strong acids and bases can be found at the ends of the scale, while those near the center of the scale are weaker. Right in the middle, at exactly 7 or pH neutral, you have pure water. Acids contain hydrogen ions, while bases contain hydroxyl ions. What are ions? Well, they're just atoms that have either gained or lost electrons. In bases, you find hydroxyl ions that have gained an electron. The hydrogen ions you find in acids are hydrogen atoms that have had an electron knocked off. These hydrogen ions are always trying to get their lost electrons back, and they'll steal electrons from anything handy. That's why when you put something like a metal in acid, the metal starts to dissolve. Bases have the power to neutralize acids. Well, watch what happens when the two combine. The hydroxyl ion shares its extra electron with the hydrogen ion. That solves that problem. The hydrogen from the hydrogen ion and the oxygen and hydrogen from the hydroxyl ion combine, giving you H2O. That's water. And water, you remember, is pH neutral. Different kinds of salts are also formed, depending on the types of acids and bases involved in the reaction. When Moby poured the baking soda, a base, into the vinegar, an acid, a reaction occurred. The vinegar combined with the baking soda to make salt, water, and carbon dioxide. Carbon dioxide was what was in the bubbles. There are also substances called buffers that can block changes in their pH for a period of time. You can find them on buffered aspirin, where they keep your stomach acids from dissolving the medicine too quickly. They're made by combining weak acids and bases. Buffers also occur naturally in the human body, helping our blood to keep its pH at or around 7.4. Finding a solution's pH is easy if you have the right tools. Most science labs have a bit of pH paper lying around. These strips are soaked with a chemical indicator, and they turn red when you dip them in an acid. A base will make them turn blue. Compare that color to a chart, and you can see how strong that acid or base is. pH is important outside the lab, too. Living things rely on constant pH levels in their environment. If a body of water becomes too acidic, the acids will dissolve the metals in the water, and the fish in it will get sick. And if acid rain caused by pollution seeps into a farmer's soil, the crops may not grow. The constant reactions of acids and bases keep our environment from becoming too acidic or too alkaline, which is a good thing for life in general.
Now, let's see if we can be able to name some of the acids that are present in these items that are going to be listed. This is sweet orange. Is it acidic or an alkali? You tell us. Oven cleaner. is it acidic or an alkali? Grapefruit, is it acidic or an alkali? Vinegar, is it acidic or alkali? Baking powder, is it acidic or alkali? Car batteries, is it alkaline or acidic? Soda water, is it acidic or alkali? Indigestion tablet, is it acidic or alkali? So these are examples of some of those things that we have talked about, and you will be the decider of whether to tell us or not. Now let's look at this again. This is lemon with sour taste. Is it acidic or alkali? This is a substance that can be corrosive. Do you think this substance will be an acid or an alkali? This substance has a high pH of what? 9.8. Will it be acidic or alkaline? It produces carbon dioxide when reacting with a metal carbonate. Is it acidic or alkali? This substance has a pH of 3.52. Is it acidic or alkali? If it's acidic, is it a strong acid or a weak one? If it's an alkali, is it a strong one or a weak one? Produce salt and water in a natural reaction. Is it acidic or alkali? Soapy filling. Is it acidic or alkali? Are usually carbonates, hydroxide and metal oxides. What are they? Alkali or produce hydrogen when reacting with some metals? Well, you may not be able to fathom this, but actually acid is one that actually produce hydrogen ion when reacted with what? Some metals. Okay? Car batteries, what are they? Are they alkaline or acidic? Household cleaners, are they alkaline or acidic? You just continue to identify this in lemon, stomach acid. Are they, which of this is alkaline, which of this is acidic? Vinegar and cleaning agent, oven cleaner, which of this is acidic and which of this is what? Not acidic. So basically, this brings us to the end of the lesson, and it's our sincere hope that you have learned a lot, which you are going to be able to use in your everyday life. Thank you for listening. I remain your humble teacher, Teacher Haruna. Stay safe and